that for more Microsoft webcasts, you can go to microsoft.com/webcast. Thanks again for joining us on today's presentation, 24 Hours of SQL Server 2008, Analysis, Services, Design, and Performance Improvements. Now it's my pleasure to introduce today's presenter, John Weston. John, you have the floor.
Thanks, Phil, and good afternoon or good morning to everyone. Welcome to the webcast here. I'm calling from Dallas, Texas, where it is a bit warm today. They think we might actually reach 100 degrees after a very cool spring we've had so far. So sit back, get yourself a nice cool beverage if it's warm where you are today or when you're listening to this recorded at a later time. And let's talk about SQL Server. Just a couple of housekeeping things before we get started. People always ask for my email address. And it's real simple. You can do john.weston@microsoft.com, or you can shorten up the first name, so jweston@microsoft.com. Both of those will get to me. If you got any technical questions, we'd love to hear from you. You can send me an email on anything related to SQL Server, communication server, Exchange, all the way Windows products, you name it. Would love to hear any technical questions that you've got. Also, I maintain a technical blog, and that is at blogs.technet.com/jweston. Lots of fun, great technical tips up there. Need to get to know me a little bit more personally. All kinds of fun stuff is up there on my blog, and you can also communicate with me via that blog. So this afternoon we're going to talk about Analysis Services Design as part of this 24 Hours of the SQL Server series with SQL Server 2008. So let's talk about what we're going to cover in this particular session. Let me get this slide all the way built out with its 5 bullet points here. So as you can see here, we're going to cover 5 basic areas. In this series, we're going to review SQL Server 2008's business intelligence features from the perspective of our good old Contoso.com, or our fake company Contoso. To support high-level and ad hoc analysis, Contoso will develop an analysis services database. In this session, we're going to take a look at the new features in analysis services that help Contoso accelerate development and achieve some optimal performance with their SQL Server design. First, we're going to take a look and review the improvements made to the cube and dimension wizards. We'll also talk about best practice warnings integrated into the development environment of business intelligence. Then we're going to take a look at the new attribute relationship designer, as well as improved aggregation designer. And then finally, we'll also review the performance enhancements that have been made by possible block computations, so we can remove block computations and speed up the performance of your queries. Some assumptions we're going to make throughout this session is you have a little bit of background with SQL Server or similar database technologies. We may explain some new terms and concepts, but with also some common terms and using other versions of SQL Server may not be explained in detail. So things like a database, I'm going to assume you already know what a database is, a form, those kind of things. So, and that you've done some type of analysis services before. But if you haven't, don't worry. We won't get into too great a detail. As you can see here, this is a level 300 course or 300 level of information. So hopefully it'll hit you right on the right level to what information you're looking for. Today's part of this 24 hours of SQL Server is the business intelligence features of SQL Server 2008. Our focus today is going to be the improvements made in the analysis services. We'll begin with a quick review of the overall design goals of this release of analysis services, and then we'll review the features that helped us accelerate the deployment cycle of analysis services database with a better interface for you to use in your environment. We'll also take a look at how the development environment highlights the opportunities for you to incorporate best practices into your database design. Then we'll take a review of how better to control the aggregation design and the improvements in the formula engine and high-level performing analysis services databases. So with anything, we're always going to start off with what were our design goals and what we were trying to accomplish by this new version. With analysis services had many wizards to facilitate the development of database objects, such as dimensions and cubes. There was room for improvement in this design environment. So we took a look at what we had with 2005. First, the dimension and cube wizards have been redesigned for ease of use. These wizards have been streamlined to minimize the number of selections you need to make to be a usable result. In addition, the dimensions editor has been modified to make it easier to work with multi-column key columns, and the attribute relationships can be created, modified, and viewed much more easily. Another big change that we made to the design environment is the embedding of best practices. These wizards produce a best practice design for you whenever possible. Then as you make changes to the design, you'll see alerts highlighting the opportunity to improve as a best practice. The net effect of the interface redesign and the best practice warnings is to help you produce a well-designed analysis services database with a minimum amount of effort and without the need to study a 100-page white paper first before ever getting started. A challenge for many developers in the new analysis services has been the complexity of the interdependencies in the OLAP design that ultimately affect the query performance. The goal of this release of analysis services is to help you naturally produce an OLAP design that performs well. Let's take a closer look at how the user interface has changed. Begin with the Cube Wizard. Now, I hate screenshots here, but we'll just give you a couple of them, and we'll dive right into the product here in just a second. The Cube Wizard is the Analysis Services 2005. In some cases, did not produce the desired results you were looking for. For example, there was no support for the design scenarios in which one wide table contained all the columns for a cube. And another example, the output of the Analysis Services in 2005 Cube Wizard was too complex. There were too many attributes created and the member properties were not identified properly. These problems are now corrected with the new Cube Wizard Analysis Services 2008. In addition, these pages of the Cube Wizard have been streamlined to reduce the number of keystrokes required to produce the desired output. A lot of all those next and next, wizard steps have been removed. The Dimension Wizard in Analysis Service 2005 required you to do a lot of manual changes in the Dimension Editor after running the wizard. So the goal of the redesign of the Wizard of Analysis Services 2008 was to streamline the interface as well as to minimize the number of manual changes required for most dimensions. For example, when the parent-child dimension is identified, the parent-child attributes are created automatically in the dimension. In addition, the assignment of the attribute type can be made easily within the wizard now. You can also easily classify selected attributes as member properties. That is, you can identify the attributes which are required to support these calculations or to use in certain reports, but which are not used in ad hoc analysis. The default error configuration for dimensions has also been revised. Specifically, rather than ignore duplicate keys, which is the default setting in 2005, the processing engine will now stop when a duplicate key is detected. Similar processing will stop when a key is not found or when a key column is null, whereas these settings would not stop any processing analysis in 2005, allowing you much more granular control of the way that your analysis are going to perform. All right, enough of the screenshots. Let's go in and actually take a look at the demonstration of how the Cube Wizard and the Dimension Wizards help you quickly build an analysis services database. All right, so let me go to my view sharing here. As you can see, I'm running the new Windows Server 2008. Excuse me. Sorry about that. So let me go ahead and log on here to my environment. You only want to be able to make this full screen. Press F5 will get you a full screen so you can see everything that I'm doing. If I can remember to type the word password correctly, there we are. So I'm going to click on our SQL Server Business Intelligence Development Studio. So this will take it just a second for this to come up. In this demonstration, we're going to take a look at the OLAP developer scenario as assuming we're the company Contoso. The sales manager wants the ability to analyze sales by date and product. We'll use the rapid development features and analysis services to create an OLAP database supporting these analytical requirements. So let's open this tool up for the first time here. All right, so we can see we're in analysis services. And to open, I've done a pre-save project here. So I'm going to do File, Open, a previous project that I've built. And instead of there, I'm going to search on drive C. Let me navigate to it. MSDN content. SQL demo files, there it is, there's my Contoso. So this will take it just a second for this to load. There we go. Let's start by reviewing the data source view. In this scenario, only one fact table is defined and the selected dimension tables are included. Friendly names have been assigned to each table to remove the fact and dim prefixes. Okay, so I'm going to go over to my Solution Explorer over here on the right-hand side. And if my voice is ahead or behind your screen refreshes, I apologize. So we're going to try to explain exactly the click steps that I'm going through here because what you see might be slightly delayed from me talking about it. I'm going to go to the Contoso DW. So here's my data warehouse. That's my source view. Okay, and I'm going to double click on my source view here, and that'll change everything that we see in our diagram here. Okay, so this is my reseller sales. You can see the relationship here between the different fields. So I've got date and reseller sales as my primary two tables. One of the fact tables defined and the selected dimension tables are included. Friendly names have also been associated for everything that we need. Also notice the names calculated in the date table here. So let me go down to the date table. And if you click on it, notice if we go to the bottom of it, so I got to kind of scroll down here. There we go. Notice quarter and month. Notice the little symbol next to it. Those are calculated fields. Okay. So this is a quarter of the month, or the values of the month created to composite label to produce a one-to-many relationships from the year to quarter and to month across all data combinations. Okay, so let's take a look at how these are actually built. So double click on month here. Okay, so we can see the calculation there of what it takes to be able to do that. So it's going to convert the calendar year into an 8-month English month name for us. So it's going to do the calculated field. All right, so now let's take a look at the Cube Wizard. Okay, so if I go up to the Solution Explorer here, and I go to the Cubes folder, okay, and if I right mouse click here and create a new cube, we're going to walk through the Cube Wizard. Now notice this number of steps here has been dramatically reduced from previous ones, so obviously we can do away with this intro slide. And I could use the existing tables. Okay, it is possible to build one of already existing data structures which are defined, or I can build an empty structure. So if I created an empty cube, this design objects manually and generates the tables in SQL Server supporting the OLAP design, or I can build those components at a later time, or I can generate tables in the data source. I can use predefined templates to modify the existing design and generate the tables later. Okay. In our scenario, we're going to use the option to create a cube from the existing tables. So I'm going to use my existing tables here, so I take it back up to the top choice there, and we're going to click on Next. So it's gone out to that Contoso DW, the data warehouse that we had, and brought in all the tables that exist. Okay, so now I'm going to select my reseller sales, and click on Next. Then it brings up a select measures. This is the measures that we want to include inside of our cube. So let's see what I want to do here. First I'm going to do is I'm going to clear everything. So if I clear the box here, notice it's going to clear everything, and it tells me I have to have at least one. So we're going to go down and find order quantity and sales amount. There we go. Okay, so I only have 2 clicks so far, order quantity and sales amount. Let's look at some of that in detail. If I right mouse click on order quantity, and let me see if I get the right box here. And notice it'll allow me to change the name of order quantity. So I can change the description at this point, and we'll call it reseller order quantity. Now notice I'm not going to capitalize this. Obviously I would want to for consistency purposes, but I want to be able to see it later so I can tell where I changed the things here. Now it helps if that letter Q gets pressed. There we go, Q-U-A-N. And if I could spell correctly, there we go. Reseller order quantity. So we've changed the name of that field at this point, as well as going to be put into the dimensions of our cube. All right, so we got those 2 changes done. So let's go ahead and click on Next. We'll see the dimensions to include. In this scenario, because we'll create the product dimensions using a dimensions wizard laser, we can clear this selection. In addition, the reseller sales is used exclusively as the fact table in this scenario, so we must clear this section also. Okay, so I want to go ahead and this one, clear the product. So I'll clear that dimension right there. And I want to the reseller. So all I'm going to be pulling in is a date or a time function. All right, and so the next one is completing the wizard. I'm going to give this cube a name, and we'll call it sales just for simplicity purposes here. And click on Finish. So now once my Solution Explorer populates again, notice I now have a sales.cube. Okay. Also, the date dimension is added to the project, and associated with the cube are the 3 role-playing dimensions: ship date, due date, and order date. So let me show those to you. So there's our date dimension. Okay. And let's go ahead and double-click on that date dimension. And there's where we're able to see the ship date and all the information that we have in our date dimension. So let's look over in our attributes. So there's my date key, and we can see all the information that's there. Now let's see how to revise the dimension wizard. Okay, so I'm going to go to my dimensions folder over here, And I'm going to, after the fact, change and create a new dimension here. So right mouse click on Dimensions and click a new Dimensions. Notice the options for creating new dimensions here. As a cube wizard, we can build the dimensions from a table that is already in your data structures view, or we can build it from something else. So we could use an existing table, or we can define a time dimension in the data source and generate a time table in our data source view. The wizard will populate the table for us as well as for the first time. But if our date range isn't far enough out in the future, we'll need to find a way to keep adding new dates to the table. Alternately, we could also define a table on the server and create a server time dimension that exists only within the OLAP database and has no corresponding physical table in the data source. Or finally, we could generate a non-table as a table source. Okay, but in our scenario here, we're going to use the option to create a dimension for the existing table. So I'll go back up and pick that first choice up here, and we'll click on Next. Now it wants to create the dimensions based upon the product table. Notice the key column that is selected. We have the option to add more columns to address situations where a composite key is required to make the dimension member more unique. So here in the Solutions, specify the Solution Source page. We're going to go into the main table drop-down list. All right, and instead of date, we're going to pick product. In the name column drop-down list here, okay, so notice down here at the bottom, we're going to search for English product name. English product name, there it is. And then we're going to click on Next. We'll keep the default selections for the related tables, and we're not going to make any changes there. So it's going to automatically bring any related tables that we need. Next, we need to select the attributes for the dimensions. On our Select Dimensions Attributes page here, we're going to select the following attributes. Okay, so the first one is color. So I highlight color. Then I want list price and size. Here's a new feature in the Dimension Wizard. We can disable browsing for the list price. The attribute will be used for reporting but not for analysis. That is, the user will not be able to put this attribute in the rows or columns. This is a quick way to set the attribute hierarchy enabled property for multiple attributes on a single screen. So let me show you how to do that. So on my list price here, notice enable browsing, and I'm going to clear that checkbox. And that's all we have to do to change those settings for the user. And I click on Next and say completing the wizard. Any changes there? Nope. We're going to leave the name. Yeah, we'll just leave the name product and click on Finish. Now let's add some dimensions in the sales cube. Okay, so now notice that we had the date dimension and now we've got a product dimension. Okay, so I'm going to go back to my sales cube and double click on it. Okay, so there's my sales cube. And now I'm going to right click in the dimensions pane over here and right mouse click and tell it to add a cube dimension. In the Add Cube Dimension dialog box here, I'm going to select product, that one that we just built. Okay, and click OK there. Now let's clean up the date dimension. Okay, so we've rebuilt and we've associated that product dimension we just built to the sales.cube or sales cube that we had defined in an earlier session. So this date dimension's got some problems that we've got. Remember that the Cube Wizard created only a very basic dimension. First, we'll need to update the name property of the date dimensions in the dimensions key attribute. Okay, so here I'm going to go over to the Solution Explorer and go to the date.dim. Okay, and I'm going to go down here to the attributes, and I'm going to take a look for, what do we want to do? Let's go to the name box, and let's see if it'll let me change that. Let's see, am I in dates? I probably didn't click on date. Yeah, double click date. There we go. I didn't double click on it, I only single clicked on it. So name, instead of the date key, we're going to change that. And the properties pane, let's go ahead and change the text there to date. All right, that looks good. Now let's go to our date source view. Okay, so that's the column over here in the third column. So I've got attributes, hierarchies, and date source. I'm going to go to the date source view and find calendar year. Okay, so let me go down to that. There's calendar year. And we'll add calendar year, quarter, and month to the attributes columns. So I'm going to take the calendar year and drag it over here to the attributes pane. So watch what happens here. Notice how it adds that to that. I'm going to repeat those steps for both quarter and month. There's that calculated field, quarter, and then finally month. Okay. Let's set this calendar year and quarter as composite keys in the key column properties for the quarter attributes because the integer values are better for dimension processing than the string values currently assigned to this attribute. Okay, so I'm going to go to the attributes pane here and click on quarter. And now if I come over here to the properties of quarter, the key column, all right, we're going to look for, let's see which one do we want, the key columns here. So let's see if we can find key columns there. There should be in a little ellipse. So notice that little ellipse that comes up. I'm going to select the little ellipse. And I'm going to go here and I'm going to take calendar year and move calendar year over to the right. So I did calendar year and add it here. There we go. And I want to make sure calendar year comes before quarter, so I need to change the sequence here. So now it's calendar year and then quarter. Good. We've got that attribute doing what we want. And then let's set the name column properties of the quarter attribute. This step is required whenever you use a composite key. So now I'm going to go to the properties pane in the name column property. So this one here. And notice the little ellipse again comes up for me. And I'm going to select quarter for here. There we go. Everything should be the way I want to do that so far. All looking good. We also need to set the calendar year and the month of year as a composite key in the key columns property for the month attribute. And also serves 2005, the interface required some extra steps to complete this task. Now in 2008, the user interface is streamlined for composite keys. All right, so I'm going to go over the attributes pane here. So under attributes, click on month. In the properties pane on the lower right-hand key, I'm going to come over here and look for under the key columns and click on the little ellipse. And under key columns, I'm going to take calendar year and drag it, or I actually can use the arrow there. Click on month, and I'm going to remove month here. And then the final thing I want is the month of the year, and add that. Oops, let's remove that one. Sorry. Let's try that again. All right, so I removed month, moved month back over here, and I've added calendar year and the month of the year and got everything the way I wanted it in that composite key date. Let's set the name column property of the month attribute here. So I go to the name column, click on the ellipse here, and we're going to select month. There we go. Much easier to do than it was in previous versions. None of the dimensions or attributes have a time intelligence applied when we use a cube wizard. So to add the time intelligence, we launch the business intelligence wizard. Okay, so I'm going to go up to my toolbar here, and I'm going to select the dimensions structure page. Okay, so let me make sure I'm doing the right one here. Under dimension structures, I'm going to add business intelligence. And you can show you we can find the wizard here, all the way on the left. There we go. So this launches a wizard for us. Click on next for the welcome page. Okay, now I'm to the choose enhancements. And so here I want to select the define dimensions intelligence. So the second one down here. Notice what it says. We use the dimensions intelligence to specify a standard business type for the dimension and its attributes. Client applications can use this metadata when analyzing the data. So click on next. On the define dimensions intelligence page here, we're going to select time. There we go. Here we map the attributes to the attributes of the dimension. At this point, we have a fairly simple cube, but it meets the analytical needs of the sales manager so far. So we're going to go back to the presentation here, but there's one more thing I've got to do. In the dimensions attributes list, select the year checkbox. So I've got the year here. So I've got, notice it's pulling the date. In the dimensions attribute, then I want to select calendar year. So I've got to scroll down here until I find calendar year. You can see lots of different dates here. All right, so year is selected, and we've got the date there. And so we got calendar year there. All right, so now let's go to quarter. And what do we want to map quarter to? Map quarter to that new one we just defined, quarter. And month, we're going to map out to, notice the default is date on each one of these. We'll map out to month. And then date, we'll let that one go to the default of date. And click on next. And you can see the summarization of what we built there. So our new date time attribute is calendar, quarter, month, and then date. So we've built that whole hierarchy within this structure, and we're good to go. All right, so that concludes our first demonstration. And let's go back to, if you want to do F5, again, we'll take you back to the full screen or non-full screen mode so you can see everything that I've got here. In that one, we took a look at all the changes in the design interface with Analysis Services 2008. Next, there's some talk about best practice warnings. These help you produce a well-designed, high-performing cube. Best practice warnings identify recommended design changes to improve the query of processing performance or to enhance the user experience when navigating the cube. The design best practices cannot always be built in the wizard explicitly, but neither nor should you require it to read a 100-page white paper before you can understand good design of your OLAP databases. The visual indicators will appear in the user interface when best practice violations are detected. These are visible but not annoying. Okay, let me show you what those look like. Build the screen all the way out. There we go. You can hover over the cursor of the warning indicator to view the explanation of the warning. You can decide to dismiss a warning globally within the database so that it never appears to you and continues to add objects to the database. Or you can dismiss a warning in each instance to which it applies. In either case, you can document the reason for the dismissing of the warning. One area that you will commonly see affected by warnings is the attribute relationships. Attribute relationships are an important part of Dimensions design. The graphical editor moves the design of the attributes from the Dimensions editor page where the relationships were hard to see across multiple attributes. Through better visualization attributes relationships, you can avoid the unintentional creation of multiple redundant relationships which contribute to query performance problems. This designer also helps you see at a glance whether the attribute relationship is rigid, as shown here, or flexible. Defining the correct relationship type will affect the dimension processing and management of the aggregations, which ultimately has an impact on your query performance. Let's go back to our design environment here and show you what this looks like in production. So let's go back over to our demo sharing area. Remember, pressing F5 will get you to see full screen everything that I've got going here. All right, so now let's go to the attribute tree. I'm going to go over the blue date dimension. Notice right here under the bottom of date, it's got that blue little squiggly line here. And if I get my mouse just right, notice it says create hierarchies in a non-parent-child dimension. Okay, so that's the way of telling us the warning. All right, so we're going to create this hierarchy as recommended by the warning. We'll create one using calendar year, quarter, month, and date attributes. All right, so in the attributes page here, I'm going to drag calendar year over to the hierarchies. All right, and then I'm going to drag quarter to the next level underneath calendar year, and then I'm going to drag month to the next level below that, and then finally date. Notice it has the key to it to the next there. So I'm building hierarchy, calendar year, quarter, month, and then date. And I'm going to, this hierarchy here, I'm going to right mouse click and rename it, and we'll call that one the calendar. Okay? So notice I can rename my hierarchies as I go along there. Although the user hierarchy is now created, another best practice warning is still activated for this dimension. Notice that all the user hierarchies, so if I click right on that little blue arrow there, user hierarchy displays a best practice warning. We'll correct the user hierarchy warning later in this demonstration. So I've got to have the mouse right on that little blue squiggly line there to see the warning message. There it goes. And notice that the one in the attributes has changed here. All right, so let's go up to our database menu now and click on Edit the Database. And notice down here at the bottom, we've got a list of errors and warnings. And let's take a look. I should have some error messages that show here. What you can do is you can turn on or off these. No, let's see if I can't get any. Let's go ahead and reprocess it there. There we are. Okay. I just didn't process the cube and to see what those warnings are coming up there. So let's go to warnings here. And let's take a look at the error messages that we're getting. So there is the attribute relationships do not exist between one or more levels of the hierarchy. This may result in a decreased query performance. Okay, so what do I want to do to this? Okay, so if I do the checkbox, I can clear this, and I can put a comment. Okay, so it allows me to be able to take a look at those warnings and clear these. I can put a comment next to them if I wanted to clear them. And if I go to dimensions design, there we go. So we can see all the different error messages that we've got there. And then there's avoid using hierarchies that are used as levels in the user interface. And again, there's our non-parent warning. So all these error messages tell us what kind of problems we might have, and we have the possibility of clearing those if we want to clear them as well as we want to. All right, and let's see, where else do I want to go ahead and show you the changes here to that. All right, let's go back to Solutions Explorers and take a look at the date dimension. And let's go to my attribute pane there. Okay, notice we've got still the squiggly line there, and I can remove that if I were to clear that error message if I wanted to do that and deploy that successfully. Let's go ahead and save out our project as we've got it at this point. Let's go ahead and let's go ahead and deploy this. So Contoso, before I save it, my machine's getting a little slow on me here, so bear with me just a second. I was trying to open up a toolbox I didn't want to do. Sorry about that. Haven't loaded that before, so let me grab a drink of water right quick while we're waiting on that toolbox to load. Hold on just a second. All right, I'm back. My poor little external hard drive's going crazy trying to pull that up for the first time. There it goes. All right, so let's take this solution and let's go ahead and deploy it. And deployment will take a few seconds. We should see those same warning messages that we haven't cleared up yet. When we dismiss a warning, it no longer appears in the error list. We can review dismissed warnings in the database error and reinstate any warnings if necessary, so you can bring one back in if you want to. All right, that looks like that got deployed successful. There we go. We can see the different warnings that we have out there, and I can dismiss this one, and I could add additional comments if I wanted to. Removed by John Weston, and I could give it a date if I wanted to do it and all that kind of stuff. So you can see they get removed from the list there. All right, so let's go back up to our dimensions here. And again, notice we have underneath calendar that one has now disappeared. Okay, so that tells us that all things are successful there, and we shouldn't have to make any more changes. So all of our error messages have been dealt with, and things are good. All right. So now let's go back to the slides for a little bit. Let's go through some review questions, see if you've been paying attention today. In the Cube Wizard, it requires you to build the dimensions and fact tables before you run the wizard. True or false? And polls are open. Anybody out there listening want to vote? Ah, there we are. Someone says true. Anybody else think that disagree with that statement? I don't think anybody wants to play with polls today, but it actually is false. When many developers build fact tables and dimensions for the first time, they think the Cube Wizard you have to have all that done. In fact, the Cube Wizard allows you to build an empty cube structure or to build a structure based on a predefined template, which then can be used to generate tables later in your SQL Server database at a later time. So the answer to that one is actually false. It's not required that you build it ahead of time. Let's try one more here. How can you Clear a best practice warning from the user interface. A, correct the database design. B, dismiss the warning in the error list. C, well, you saw me do that one. Or C, dismiss the warning in the database editor. Or D, all the above. Most of you are getting this one right. Actually, getting 100% of you getting this one right. D, all the above. Way to go. Good voting there. Good review questions. All right, let's move on to the next topic in this session. Aggregation. Aggregation design is an important task at the development of the analysis services database. In this next section of our presentation, we'll explore the improvements both in aggregation design wizard and the user-based optimization wizard, and we'll also introduce the new aggregation designer. Let's start off with a review of the improved aggregation design wizard. So again, we got another screenshot here, but we'll see it in production here in just a second. And let me build this thing all the way out. There we go. The aggregation design wizard is very similar to the wizards found in analysis services back in 2005. The main change in this wizard is the addition of the aggregation usage properties. You can use the dimensions editor to set this property for each attribute, but you can more quickly and easily make changes on the review the current settings using this interface. As a reminder of the aggregation usage settings, the default settings is to let analysis services determine the aggregation behavior of an attribute. If you select full, the attribute will then be included in every aggregation or related lower level attribute that is in the aggregation. It's important to avoid this setting when the attribute has many members. If you select none for the aggregation usage, the attribute will be excluded from all aggregations. And finally, if you choose unrestricted, this attribute may or may not be used for aggregation. Another change is the ability to name the aggregation design. You can then reuse a specific aggregation design when working with multiple partitions from a measure group. You can now work with aggregation designs using the new aggregation designer. The advanced view in the aggregation designer is shown here. This allows you to view the aggregation designs for each partition. You also can add, change, or delete aggregations and aggregation designs. In the standard view, you can also launch the aggregation design wizard or the usage-based optimization wizard, and you can also assign the aggregation design to another partition within the same measure group. Incidentally, aggregations have best practices too, so if you may see warnings displayed here, such as in the aggregation design, this is not assigned to a partition. Let's take a quick look at the usage-based optimization wizard. The usage-based optimization wizard has been modified slightly for Analysis Services 2005. You can now name a design just like you could in the aggregation design wizard. You can also merge a new usage-based design with an existing aggregation design. Let's take a look at these in a demonstration. So in our third and final demonstration here, we're going to take a look at the aggregation design wizard and the aggregation designer to add an aggregation to a cube. All right, so again, remember F5 is our screen to toggle back things into full screen. We need to continue to refine the database design we started in the previous demonstration so we can deliver great performing queries to our Contoso users. Adding aggregation designs to the cube is an important step towards meeting these performance goals. In the Cube Designer, we have a new tab for designing aggregations. From here, we can launch the Aggregation Design Wizard. Okay, so I'm going to go back to my Sales Cube. So over here in Solution Explorer, double-click Sales Cube. And then notice I've got an aggregation, and I have to find it here. Let's do actions. Nope, here's our aggregation. So notice the one with the little thumb sign here. If I had enough screen real estate here, it would say aggregation. So this is our aggregation design, our design aggregations. All right, so I'm going to do reseller sales. That is highlighted. And what I want to do here is design aggregations. So I click on this first left tool here. Let's change the aggregation usage of the order date dimension to full. Remember, the full should be used with caution and only used when the attributes have a low number of members, such as a year in our case, because the data warehouse only has 4 years worth of data. So I'm going to go ahead and click on Next here. And we're going to select this to full. All right, so what I want to do is in the order date, so coming down here to order date and calendar year, we're going to select that to full. Okay, notice the warning dialog box that we get. Click OK there, and click on Next. We need to update the counts to use the actual row counts in the source tables before the aggregation design can be analyzed. Okay, so now my specific object counts. All right, we're going to click on the count button here and go out there and see how many rows we have in our table. 60,855 looks like what we've got. And click on Next. And now I'm to the Set Aggregation options. A common strategy used by OLA developers is the set the option to improve performance gain, which will impact the aggregation calculations on the server right after processing the cube. Let's keep the default settings for performance gain. So if I go ahead and click on Start, there we go. So it's going to go ahead, and as you can see, it's going to the optimization level. Looks like we're going to get, there we go, 73% optimized. All right, so notice I could also do some changes here to select the aggregation options. And I could select the performance gains and stop it at 30%. So let's go ahead and continue there and have it reset that and start the aggregation over again. Now notice the changes that we'll see here. Once it reaches 30%, boom, we're done. Okay? So I can go ahead and click on Next here. And you really have your total choices here of how you want to do that. In the name, I'm going to do 30%. And I could deploy it and process it now, or save the aggregation and process it at a later time if I wanted to do that. All right, so now notice we have that 30% there if I wanted to do that under the reseller measure group. Next, let's take a look at review the aggregation design. So if I go to the aggregator design toolbar, click on the advanced view button. So let's go to advanced view. And here in the aggregation design drop-down list, I'm going to pick that 30% one that we just ran. And on the sorting drop-down list, notice the different ways we can sort it. And also I've got the range settings that I could set there. Okay, and then notice how I can expand out all these different dimensions that we've got. Very nice attributes, allowing me to be able to look at all the attributes of those different dimensions. Now look at the combinations of all these attributes created for each aggregation. The checkboxes allow us to add or delete aggregations from the aggregations if we choose. Usually, however, the aggregations designed by the wizard perform optimal performance before usage-based optimization can be implemented. Notice there's no aggregations for the key attributes in any dimension because the attributes count is too high. Now that we've added the aggregation design to the cube, our development work is done for this simple cube. Now let's return to the presentation to review what we've done so far. All right, we've got some more review questions for you here. Which aggregation usage settings should be used only when an attribute has few members? Default, full, none, or none restricted? Well, you guys are hitting it right on the nail of the head. 100% correct. B is the correct choice, full, because every aggregation will include an attribute with the aggregation use is set to full. You should only use this setting for an attribute that has a limited number of members. Y'all are paying great close attention. One more for you here. Which functions can you perform using the aggregation designer? Add a new aggregate to the design, change the attributes in the aggregation design, delete the aggregation design, or D, all the above. And again, y'all are doing great here. It is D, all the above. The aggregation designer gives you complete control over the aggregation design process. All right, one last thing we've got to cover here. Block computations is a term used for describing data retrieval from analysis services in 2008. We start first from a look at the traditional cell-by-cell computations as performed by 2005. Then we'll take a look at the logical block computations and review an example of the block computations in action. Let's consider a scenario in which we have a calculation that finds the percentage of the contribution of a product to its parents. It's possible that the numerator in this expression could contain null values. As seen here, furthermore, it's possible that the denominator in the expression could contain null values. The resulting calculation expression would lay out in a grid. like this. In Analysis Services 2005, the default value of the null gets looked up, and then is returned for the query cell by cell. This approach consumes processor time and increased query time. So for example, let me go through the process here. Let me build this out. You can see all the different ones to build cell by cell, how long it would take to calculate. The process is going to repeat. The lookup is performed for the Europe cap sales amount and the numerator, and the Europe clothing sales amount as the denominator. Then the division is performed, returning the null for the null divided by null. This process is repeated for jerseys and socks. The same process continues for North America sales territory group. And for North America, and here the actual values are then finally retrieved. And finally, the process completes after lookups in the Pacific sales territory group. A total of 16 lookups or calculations were performed to complete this query. Even though the empty cell is visited only once is known to be empty, such as the parent cell of clothing or Europe, this causes problems. This problem is especially prevalent in sparse cubes because every product is not sold in every location and every day. There are a lot of opportunities for time and location-based queries to return into nulls. Cell-by-cell computation is also a problem for cumulative calculations. For example, in year-to-date calculations, performance is satisfactory for early cells such as January and February, but decreased later months such as November and December. Let's consider the logic behind changing the computation scenarios to block computation. Modifying these calculators to evaluate only when values are returned by the storage engine will only partially implemented in Analysis Services 2005 and resulting performance improvements in some situations, but the improvement was not complete. In 2008, we made some changes. The goal is to only calculate non-null values, or more correctly, default values. Cell navigation to parent or previous member should be performed only once to input entire space. In the case of cumulative calculations, the savings can be as high as much as 1,500%. Yes, it's a dramatic number, but it's not uncommon. However, don't expect the savings calculation time every time. It only improves for certain types of queries against sparse cube data space. Let's consider the logic behind block computations. We know that the query of the numerator A is always the current member of the product dimensions, and we know that the denominator B is always the parent of the current member. Now, if A is not null, we also know that A divided by B cannot be null. We also know that in this calculation, B is always constant for the current sales territory group because we're always getting the specific category clothing. Therefore, the storage engine should not run non-null data only. In other words, the storage engine should return data only when A is not null. In summary, these calculations need to be evaluated with the numerator can be returned by the storage engine and the denominator is a consistent value. Let's look at the same calculation as a block computation. If we look at the same calculation running under Analysis Service 2008 using block computations, the first step is to get the non-null values from the storage engine. There are only 4 non-null values retrieved in this example. Then the expression is calculated as shown here. Finally, the null values are added back to the query results. Overall, only took 4 lookups needed to perform here and compared to the 16 lookups performed back when we did this in 2005. All right, got a couple more review questions for you here, and then we're wrapped up for the day. Which of the following actions is required to enable block computation? A, set the block computation enable property on the server. B, write the query with a non-empty keyword. C, design cube aggregations, or D, none of the above. What did you see me change to talk about in that last section? It's actually none of the above, so D is the correct answer there. Block computation is automatically implemented. You don't have to do anything to get it to work. How high can the savings of block computations over cell-by-cell computation be? 100%, 200%, 500%, or 1,500%? There we go. Y'all are paying attention. 100% are getting this correct. The actual answer is D, 1,500%. Our testing has shown that block computation can deliver savings as high as 1,500% over cell-by-cell based computation. Well, let's wrap this thing up. Bringing in summary here. In Analysis Services 2008, the cube and dimensions wizards require fewer steps to complete and deliver better output, which helps you design your database, bring it together quicker and more efficiently. Best practice warnings help you achieve an optimal design out of the box without requiring you to read through pages and pages of technical manuals first. In Analysis Services 2008, you have complete control over aggregation design. You can automate the process by using the Aggregation Design Wizard or manually override the calculated aggregation design settings for the targeted solutions. And finally, today we looked at the query your cube faster than you think by block computation optimization built into Analysis Services 2008 by design. Phil, let me go ahead and turn it over to you, and I'll see if we got any questions that are out there in the queue and see if we can answer any of them online.
All right, thanks, John. And ladies and gentlemen, if you do have any questions for John, please go ahead and click on your Q&A menu in your upper toolbar, and then go ahead and type that question into the top field and click Ask. Once again, so Q&A menu, and type your question, and then click Ask. And I will turn it back over to you, John, for any questions that may have been submitted.
Looks like they've all been answered, or there are none currently out there waiting in the queue. Again, if you come up with any at a later time, don't forget to send them to me in email. It's jweston@microsoft.com or john.weston@microsoft.com. Would be glad to help you with anything you got SQL related. Thanks for joining us.
All right, thank you, John. And I would like to remind everyone that if you would like to print a PDF of these slides, you can simply click Control-P, and this will either allow you to print or save those slides locally for your convenience. Also, watch your inbox for an email with information about viewing this webcast on demand. The email will also include a link to a downloadable PowerPoint of today's webcast. And with that, I'd like to extend a special thanks to John Weston for today's presentation. Thank you all for joining us today, and you may now disconnect and have a great day.